Right. In this episode, we want to deal with two kinds of infinite integral. And the first type is when one of the limits, or both of the limits, is infinite. So let us denote the integral of x e to the minus x squared dx between the limits 1 and infinity by I. And then using a change of variable, letting u equals x squared, du equals 2x dx, and the integral will transform to the integral of 1/2 e to the minus u du, and the limits will remain the same. And carrying out the integration, that will be 1/2 bracket minus e to the minus u, evaluated at the limits infinity and 1. And then in the next step, all I've done is switch the limits to get rid of the negative sign. So that's 1/2 e to the minus u, 1 upper limit, infinity, bottom limit. And that will equal 1/2 e to the minus 1 minus 0, which is 1/2e. And I put a little note there that e to the minus u will tend to 0 when u tends to infinity. But that, I hope, deals satisfactorily with the first one. And the second kind is when the integrand itself becomes infinite, even though the limits are finite. Okay, and in this particular case, where we have the integral between 0 and 2 of dx over 1 minus x all cubed, the integrand becomes infinite when x equals 1. And so what we do in cases like this is to split the integral up as follows. First of all, have the range going from 0 to 1, and in the second part, have the range going from 1 to 2. So dealing with part A first, and well, just look at the general integral without limits. So we have dx over 1 minus x cubed. Let u equal 1 minus x, and so du is minus 2x, is minus dx, and the integral transforms to minus du over u cubed, which is minus the integral of u to the minus 3 du, which is minus u to the minus 2 over minus 2, which is 1/2u squared. And going back to the old variable, that is 1/2 1/2 bracket 1 minus x all squared. Now, putting in the limits for the first, we'll get when x equals 1, we'll get infinity as the top value, and minus 1/2 for the bottom value. And for b, we get 1/2 for the top value and minus infinity for the lower value. So our integral becomes infinity minus infinity, which is meaningless. So the integral that we've been dealing with does not exist. Thank you very much for listening.